Good morning, all of you. Hope you are doing good. Where do we stopped in the previous class? Yes, we have been discussing about quadrilaterals. And in the previous class, we discussed about the angle sum properties of quadrilaterals and do some problems related with it. Okay. And today we discuss about some special type of quadrilaterals. Before that, first of all, we have an exact idea about which are the features of a quadrilateral. So just listen here. I'm just going to draw a quadrilateral here. So how many sides there would be for a quadrilateral? There are exactly 4 sides. So I'm just drawing a quadrilateral here. A 4-sided quadrilateral. And now I'm naming it as A, B, C, D. So my quadrilateral is A, B, C, D. Clear? Now I'm considering, first of all, for a quadrilateral, I am going to consider the corners. Which are the corners? A, B, C and D. These are the corners. So, A, B, C, D are the corners. Clear? Now I am going to consider sides of the quadrilateral. Which are the sides? This would be one side. And it is A, B. So the first side is AB. The next one is BC. The next one is CD. And the next one is DA. So there are 4 sides and the name of those 4 sides have been written here. Clear? So now we are going to consider the angles of the quadrilateral. Angles means here I am considering the interior angle. Which are the interior angles of this quadrilateral? One angle is here, another one here, another one here and another one here. Clear? So how can you name it? This angle can be angle A. The next one is angle B. The next one is angle C and finally angle D. These are the 4 angles of this quadrilateral. Clear? Now I am going to consider another feature which is diagonals. So what is mean by diagonals of a polygon? Diagonals of a polygon means the line that are connecting the opposite corners. Okay. So in the case of quadrilateral ABCD, the corner A and the corner C are opposite. They are the opposite. One pair of opposite corners. And corner B and corner D are another pair of opposite corners. If I am joining the corner A with corner C, then it would be one diagonal of this quadrilateral. Clear? And if I am joining the corner D with the corner B, it would be the another diagonal. The second diagonal. So this quadrilateral ABCD has 2 diagonals. One is AC, the diagonal AC, and the other is BD, the diagonal BD. So these are the 2 diagonals of the quadrilateral. Clear? Now I am going to consider another feature called pairs of opposite sides. Pairs of opposite sides. So consider the side AB. This side AB has got an opposite side. Which is the opposite side of AB? The opposite side of AB is DC. Clear? They are opposite. Clear? So the one pair of opposite side is AB, DC. AB comma DC. Clear? So the one pair of opposite sides is AB comma DC. Clear? There is another pair of opposite sides. Can you tell me which is the another pair of opposite sides? This DA and this BC are opposite. Clear? So another pair is DA comma BC. So there are two pairs of opposite sides in the case of this quadrilateral. Clear? Now another thing we are going to discuss is pairs of opposite angles. The next one is pairs of opposite angles. You can consider the opposite angles also easily from this figure. This angle A and the angle C are opposite. Clear? Similarly, the angle B and the angle D are opposite. Clear? So, which are the pair of opposite angles? The first pair is angle A comma angle C. Now the second pair is angle B comma angle D. So these are the pairs of opposite angles. Clear? And now we are going to consider pairs of adjacent angles. So now we want to consider adjacent angles that occur in pairs. Clear? So pair of adjacent angle actually means the two angles that are formed on the same side. You can consider the side AB, and on this side AB, there are two angles formed. One at the end A and the other at the end B. Clear? Since these two angles are formed on the same side, we can consider these two angles as the pair of adjacent angles. Clear? So the first pair of adjacent angles would be angle A comma angle B, and these are formed on the side AB. Clear? Like this. There are three more sides, BC, CD and DA, and on each of these sides there would be one pair of adjacent angles that we can consider. Clear? So tell me which are the adjacent angles when we consider the side BC. It would be one angle is formed by considering the side BC. One angle is formed here and one angle is formed here. So the next pair of adjacent angles are angle B and angle C. Clear? Now the third pair of adjacent angles. This is the third side, CD, and the adjacent angles are angle C and angle D. Now the last pair is on the side DA, and the angles would be, tell me which are the pairs of adjacent angles on the side DA. It would be angle D and angle A. So these are the basic features that are related with a quadrilateral. Clear? Now there may be chances for specific relations between the sides of the quadrilaterals, or there may be chances for specific relations between the angles of the quadrilateral, and depending upon the relations between the sides and relation between the angles of a quadrilateral. We divided the quadrilateral into different special types. And now we are going to check which are the special types of quadrilaterals and what are the relations between their sides and their angles. Okay, these are the different types of quadrilaterals that we are going to discuss today. So the first one is trapezium and isosceles trapezium. The second one is kite. The third one is parallelogram. The fourth one is rhombus. The fifth one is rectangle. And the sixth one is square. Some of these quadrilaterals are already familiar with you. But here we discuss about the relations of sides and angles of all these special types of quadrilaterals. Okay, let's begin with a trapezium. I'm going to draw a trapezium here. So, this quadrilateral ABCD is a trapezium. And do you know what is the property of a trapezium, or what is the speciality of a trapezium? The speciality of a trapezium is that on that trapezium, one pair of opposite sides would be parallel. One pair of opposite sides would be parallel for a trapezium. So, on looking at here, which sides are seemed to be parallel? Here, the side AB and the side DC are parallel. Clear? There is only one pair. The AB and DC pair is parallel. Can you see the other two sides? They are opposite pairs. Thus they are parallel. No, they are not parallel. Only one pairs are parallel. Then such a quadrilateral is called a trapezium. Clear? So here the parallel sides are AB, which is parallel to DC. AB parallel DC. Clear? This is the only one condition for a quadrilateral to be a trapezium. Clear? Now, on the same quadrilateral type trapezium, there is another special type called isosceles trapezium. In isosceles trapezium also, one pair of opposite sides would be parallel. And in addition to that property, for an isosceles trapezium, there is another property, and it is the non-parallel sides are equal in length. In the case of an isosceles trapezium, one pair of opposite sides are parallel, and the second condition is the non-parallel sides, they are equal in length. Clear? Then it forms an isosceles trapezium. So if it is P, Q, R, S, then on this trapezium, the first thing is PQ is parallel to SR. Now there is one additional property, and it is the non-parallel sides. Which are the non-parallel sides? PS and QR. They are equal. PS equals QR. Clear? And there is two more specialities for an isosceles trapezium. Can you see these two angles, angle P and angle Q? They are formed on the same side PQ. And the PQ can be considered to be the base. Clear? And those base angles are equal. Angles on the base or base angles are equal. Which are the base angles here? Angle P equals angle Q. And if we are inverting this trapezium, then the base would be SR. And those angles also would be equal in the case of an isosceles trapezium. So which are the next two angles that are came to be equal? Angle S equals angle R. They are also can be considered as a base. And in the case of isosceles trapezium, base angles are equal. And now the fourth property or speciality of an isosceles trapezium is their diagonals are equal in length. Diagonals are equal in length. Can you tell me which are the diagonals of this trapezium? Diagonals are formed by joining the opposite corners. The P can be joined to R, so that one of the diagonal is PR, and that would be equal in length to the other diagonal QS. Clear? So these are the basic properties of a trapezium and an isosceles trapezium. I hope you clear. The second type of quadrilateral is a kite. Here on the board there is a kite, you can see. And the basic property of a kite is its adjacent sides are equal. Its two pairs of adjacent sides are equal. You can see that this SR and RQ are adjacent sides. And you can see here they are equal. And another pair of adjacent sides are SP and QP. They are also equal. Clear? So how many pairs of adjacent sides are equal? Two pairs. The one pair is SR, which is equal to RQ. Then the second pair is SP, which is equal to QP. So if two pairs of adjacent sides of a quadrilateral are equal, then it is said to be a kite. Now let's check what are the features of this kite. And you can see that the first feature of a kite is its diagonals intersect at right angles. The diagonals of a kite intersects at right angles. Which are the diagonals of this kite? Opposite corners S and Q can be joined to draw one diagonal. The next diagonal is by joining P and R. This is the second diagonal. And you can see that they are intersecting at right angles. Right angles means this angle would be right angle 90 degree. Clear? This angle 90 means this angle also would be 90. Then this would be 90 and this would be 90. So all those angles would be 90. Which means these two diagonals intersect at right angles. Clear? This is the first property of a kite. So we can say that SQ, that is perpendicular to PR. Clear? Or in otherwise we can say that angle, all of these angles are 90 degrees. Suppose this is T, this point is T, then QTR, STR, STP and QTP, all those angles would be 90 degree. This is the first property of a kite. Now what is the second property? The longer diagonal is the perpendicular bisector of the shorter diagonal. So you can see that this shorter diagonal is SQ and it is divided by the longer diagonal PR. And how it divides is the shorter diagonal is divided by the longer diagonal through its middle. Which means this longer diagonal bisects the shorter diagonal. Bisect means the two pieces would be of equal in length. Which are the two pieces of shorter diagonal? Shorter diagonal is SQ and the two pieces are ST and QT. They would be equal in length because this longer diagonal is bisecting it. Clear? So how can you say it? It would be ST would be equal to QT. Clear? Not only simply the bisector, it is the perpendicular bisector, which means it bisects also the angle between those two lines would be 90 degree. Such a bisector is called perpendicular bisector. Now look at the next property of a kite. Which is the next property? The longer diagonal is the axis of symmetry and it divides the kite into two congruent triangles. You can see that this is the longer diagonal PR, and by considering this longer diagonal PR, the two sides of this longer diagonal are the same and which are in the shape of triangles. Which are those triangles? Triangle PSR. This one is the first triangle. Clear? And the next triangle is triangle PQR. And they are congruent, which means they are equal. Clear? Who is dividing that kite into two equal triangles? Our longer diagonal. And thus the longer diagonal is said to be the axis of symmetry. Axis of symmetry means the axis or the line that divides that thing into two same types. The human being also got an axis of symmetry. If we are cutting us through this axis, then our both sides would be the same. So we are symmetric along this vertical line. Clear? Just like that, this diagonal is the axis of symmetry. The major diagonal or the longer diagonal is the axis of symmetry of a kite. Clear? So which are the congruent triangles? Two congruent triangles formed here. Triangle PSR, which is congruent. This is the symbol of congruency, which is congruent to the triangle PQR. Clear? Now the last property of a kite, which is the shorter diagonal divides the kite into two unequal isosceles triangles. Consider the shorter diagonal SQ. It also divides our kite PQRS into two parts. One is a triangle like this. The other one is also a triangle which is like this. Clear? And the properties of these two triangles are, did they are equal? No, they are unequal. But both of them are isosceles triangles. You can see in triangle SQR, the side SR and the side RQ are equal. So this SQR is an isosceles triangle. And the next triangle SPQ, which are the two sides that are equal? The SP and the QP. They are also equal. So again this triangle also would be isosceles. And how do these two isosceles triangles are formed? Our smaller diagonal, shorter diagonal divides our kite into these two isosceles triangles. So which are the triangles formed? Tell me. Triangle SQR, which is isosceles. Again another triangle, triangle SPQ, that is also isosceles. Clear? So these are the basic features of a kite. Clear? Here comes another type of quadrilateral, which is a parallelogram. Okay. So what is the basic feature of a parallelogram is the opposite sides are equal and parallel. So on the board, the figure you can see is a parallelogram. And you can see that I'm just naming it as P, Q, R, S. Clear? And you can see that the side PQ and its opposite side SR, they are in parallel. Clear? So we can say that PQ parallel SR. And also that PQ, the length of that PQ is equal to SR. So we can also write PQ equals SR. Now, on the second pair of opposite sides, the PS and the QR, they are again parallel lines. Okay, so PS parallel to QR. And again they are of equal in length. So PS also would be equal to QR, which means the two pairs of opposite sides are parallel as well as they are equal. Then such a quadrilateral formed is a parallelogram. Clear? What are the other features of this parallelogram? The opposite angles are equal. Which are the opposite angles here? One angle is P and the opposite angle is angle R. They are equal, which means angle P equal to angle R. Now what is the second pair of opposite angles? The angle Q and opposite angle, angle S, they are also equal. Angle Q equals angle S. This is the second property of a parallelogram. The third property of a parallelogram is in its diagonals. What is the property of diagonals of a parallelogram? The diagonals bisect each other. Let's draw the diagonals of this parallelogram PQRS. One of the diagonal would be by joining P and R, and the diagonal would be PR. And the second diagonal is QS. Clear? And the property of a parallelogram is that its diagonals bisect each other. Bisect each other means one diagonal would be bisecting the other and vice versa, which means the diagonal SQ bisects diagonal PR. If PR is bisected by SQ, suppose this is M, then these two length would be same, or we can say that the length PM, that would be equal to length RM. Clear? Now the second diagonal, which is SQ, it also bisected by this PR. This SQ is divided into two equal halves by this diagonal PR. So that we can say that the length SM and the length QM would be equal. Clear? This is the properties of diagonals of a parallelogram. And what about the next property? It is the adjacent angles are supplementary. What is mean by the term supplementary? Supplementary means their sum would be equal to 180 degree. Clear? And which angles sum is supplementary here? The adjacent angles are supplementary, which means the sum of the adjacent angles would be 180 degree. Consider one pair of adjacent angles here. Consider this side PQ, which are the adjacent angles, angle P and angle Q. You can say that angle P plus angle Q, that would be equal to 180 degree. Similarly, the next pair, angle Q and angle R, their sum also would be 180 degree. The next pair, angle S and angle R, their sum also would be 180 degree. And the final pair of adjacent angles, angle S and angle P, that would be equal to all of these pairs would be supplementary, which means the sum of all these pairs of adjacent angles would be 180 degree. Clear? These are the basic properties that you should have to remember in the case of a parallelogram. I hope you clear. See, the figure shows a parallelogram. Why it is a parallelogram? Its opposite sides are parallel and of equal in length. These two sides are parallel. Similarly, these two sides are also parallel. And they are having length the same also. There is an additional property for this parallelogram. And this additional property is that all its sides are same. All the sides are same. So, if in a parallelogram, if all the sides are same, equal, then such a special type of parallelogram is called a rhombus. This rhombus has got some other special properties. We can check which are the special properties of a rhombus. So, this rhombus I am going to name it as PQRS. And the first property of a rhombus is it is a parallelogram in which all the sides are equal. Which means all these four sides are of equal length. PQ is equal to QR is equal to RS is equal to SP. Clear? All the four sides are equal. Now the second condition, opposite sides are parallel. This would be a parallelogram only if the opposite sides are parallel. Which are the parallel pairs of sides? PQ parallel SR. Which is the next pair? PS parallel QR. Now, the third property of a quadrilateral, of a rhombus is opposite angles are equal. That would also same in the case of a simple parallelogram, ordinary parallelogram. Which are the opposite angles? Angle P and angle R. They are equal. The next pair is angle Q and angle S. They are also equal. And the fourth and very important property of a rhombus is that diagonals of a rhombus bisect each other at right angles. So let's draw the diagonals of this rhombus. PR is one of the diagonal and the other diagonal is SQ. Clear? These are the two diagonals. And the property of a rhombus is that their diagonals bisect each other. That would also same in the case of a parallelogram. But these diagonals bisect each other at right angles. Which means the angle between these two diagonals would be 90 degree. Clear? That is the speciality of a rhombus. The diagonals are perpendicular bisectors. Clear? So we can say that SQ is perpendicular to PR. SQ perpendicular to PR. And since they are bisecting each other, these two would be halves. Suppose this is M, then SM would be equal to MQ. Similarly, on the second diagonal, PM would be equal to MR. These are the basic features of a rhombus. I hope you clear. Students, please look at here. Here, the figure on the board is definitely a parallelogram. Suppose I am naming it as PQRS. Then I can see that the side PQ and SR is parallel. The side PS and QR are also parallel. Similarly, those lengths are also equal. Clear? So definitely PQRS is a parallelogram. And there is one more speciality of this parallelogram, for this parallelogram. And it is all these angles are right angles. All the angles are right angles. And if in a parallelogram all the angles are right angles, then such a parallelogram is called a rectangle. Such a parallelogram is called a rectangle. So what is a rectangle? A rectangle is a parallelogram with all the angles right angles, which means all the angles are 90 degree. Clear? Okay, now let's check out what are the other features of a rectangle. The basic feature of a rectangle is opposite sides are equal and are parallel. Which are the opposite sides? The side PQ, which is parallel to SR, and also PQ equal to SR. Now the next pair, which is PS, and it is parallel to QR, and also PS equal to QR. This is the first condition for it to be a parallelogram. Now for it to be a rectangle, all the angles are right angles. Which are the angles? Angle P, that would be equal to angle Q, that would be equal to angle R, that would be equal to angle S, which all of these angles are 90 degree. Now the next important feature of a rectangle is the diagonals are equal and bisect each other. Which are the diagonals of this rectangle? One is PR and the other is SR. Both of them are equal, which means PR equals SQ. Clear? Now the next property is they bisect each other. As in the case of already in the case of a parallelogram, the diagonals bisect each other. So how can you say it? SM would be equal to MQ. And next PM would be equal to MR. This is the condition of bisection. Clear? So this all about the basics of a rectangle. Clear? Now we are going to discuss about the last one. Last special type of quadrilateral, which is a square. Look at here. Here there is a rectangle. All these angles are 90 degree. And the opposite sides are parallel also. Clear? So this one forms a rectangle PQRS. And there is one additional property for this rectangle. And it is all its sides are equal in length. Such a rectangle in which if all the sides are equal, then it is called a square. So a square is a rectangle in which all sides are equal. Which are the equal sides here? PQ equals, QR equals, RS equals, SP. Clear? Now, a square can also be defined from a rhombus. Remember the case of a rhombus. Rhombus is a parallelogram in which all the sides are equal. So this one we can say this one is a rhombus also, because all its sides are equal and are parallel. Opposite sides are parallel also. So definitely this is a rhombus. And the property of this rhombus is all its angles are 90 degree. So we can define a square as a rhombus in which all the angles are right angles. Clear? Which are the angles? Angle P, angle Q, angle R and angle S would be right angles, which means 90 degree. Each of them are 90 degree. So this is the important speciality of a square. Clear? So a square has got all the properties of a rectangle as well as all the properties of a rhombus. Clear? In addition to that, one more speciality is all the sides are equal. Clear? So that's all about different types of quadrilaterals that we have been discussed today. All of you must be well aware of the features of all these types of quadrilaterals. You need to prepare a note based on this. I will give you a note which would be uploaded in our group. Clear? All of you should have to copy them and read it, understand and stock it in your memory. You must be well aware of all these properties of quadrilaterals. Then only from the next class onwards we can do problems related with these special type of quadrilaterals. Okay. So I hope all of you will do it. Then we will see in the next class. Bye.